I am a monic polynomial problem. So the problem is a monic polynomial f of x of fourth degree satisfies f1 equals 10, f2 equals 20, and f3 equals 30. Determine f12 plus f negative 8. So first we need to know what a monic polynomial is. A monic polynomial is a polynomial with one variable and a leading coefficient of 1. So in our case, the problem stated that the monic polynomial has a degree of 4, so that means it has a power of 4. So it'd probably look something like this. Another thing we need to know is the linear factorization theorem for this. So it says every polynomial function f(x) of degree n is greater than 0 can be factored into n linear factors of the form f(x) an x minus c1 times x minus c2 all the way to cn. So the c's, c1, c2, all the way to cn are complex numbers. So it says complex numbers, but it doesn't have to be necessarily complex. Complex numbers, remember that they are made of one real, a real part and a imaginary part. So if the imaginary part is 0, then the complex number is actually a real number. So that is for polynomial functions of degree n greater than 0 has exactly n zeros in the complex number system. So it can have n factors. So our solution, since f1 equals 10, f2 equals 20, and f3 equals 30, we can say f1 minus 10 equals 0, f2 minus 20 equals 0, f3 minus 30 equals 0. So f1 equals 10 when x1 equals 1, f2 equals 20 when x2 equals 20 equals 2, and f of 3 equals 30 when x3 equals 3. So that means x is f of x is actually 10x. So let f1x equal fx minus 10x equal to 0 when x1 equal 1, x2 equal 2, and x3 equals 3. So according to the linear factorization theorem, a 0c in the form of x minus c must be a factor. So all of these are factors from over here. So 1, 2, and 3, so x minus c, so these are the c's. And this has 4 solutions since this has a degree of 4. So we have 3 of the zeros, so 3 of the solutions, but we are missing the 4th one. Okay, so f(x) equals f1x plus 10x, because f1x is fx minus 10x now. So if we want to cancel out this minus 10x, we have to add 10x again. So now we go on to the determining f12, f of 12, and f of minus 8, negative 8. So f12 equals 120 plus 11 times 10 times 9 times 12 minus n. So this is according to our equation, and over here, and you can't even see it because of this thing, whatever. So you got 120 plus 990 times 12 plus n, 120 plus 11,880 minus 990n. So we got 12,000 minus 990n. And for f of negative 8, we get negative 80 plus negative 9 times negative 10 times negative 11 times negative 8 minus n. This equals negative 80 plus 990 times negative 8 minus n. So then we get negative 80 plus 7,920 plus 990n. This equals 7,840 plus 990n. So now we evaluate the equation. We just plug in the numbers. So we take the f of 12 numbers and the f of negative 8 numbers, put them, we just add them up. These two 990n, since there's a negative 990n here and then positive 990n here, these two cancel out, don't need them anymore. Just add 12,000 plus 780, 7,840, and we get 19,840. So that means our answer is 19,840, and f12 plus f of negative 8 is 19,840. We're done.
Okay.
Kyler,
Yeah.
So for f and bracket 12 equal 120, but I mean, like, how did you get 120? I just want to know.
Remember, we were doing. Oh my god, you can't. Like I was trying to show you, but like, this thing is just blocking it all the time, and I can't even drag it. This
Oh.
10x.
Oh, I get it.